All right, so let's get started. Okay, so draw a function that does all 6 of these things. So I was having some trouble with the formatting on Microsoft Word. This was supposed to be round parentheses. Jose, I think on the one you have, it has weird looking brackets.
Yeah.
I was fighting with Microsoft Word. But anyway, this is what it's supposed to look like. So for ones like this, the first thing I do is I look at all of the X values, which is going to be 1, 1, -1 and 1. So they're all about +1 and -1. So I need that on the X-axis. And then this part right here is saying as you approach 1 on the X-axis, the Y value will be a 1. So that's on the right. So that could be something like this, that the Y value is 1. And at this point, I don't know if it was supposed to go like this or what, but it's supposed to end up at a Y value of 1. So I'll just stick with my original. And then this part is saying if you're on the left side of 1, then it's also reaching a 1. So something like this. And then this one is saying if you follow the graph out forever, it's going to go down to -infinity. So this part is going to keep going down and down and down to -infinity. And usually what I do is I write this in pencil really light, the graph, because right now it's starting to look like a mess, but I'll clean it up afterwards. Then for this part, the derivative is positive. So derivative tells you slope of the tangent line, and if the slope is positive, then it's going up. So it says that it's going, so this is saying that it's going up if you're to the left of -1. So actually, what I drew right there is actually, that's what it's supposed to be doing. It's supposed to be going up if you're to the left of -1. And then this part is saying that the slope is equal to 0. So if the slope is equal to 0, that means it's a horizontal line. Well, now I need to piece it together. So it's going up, and then between -1 and +1, it's supposed to be a horizontal line. And then one other thing is right here in purple, that's saying that the slope is negative. So that means that it's going down to the right of 1. And then that's actually this part over here, it's going down. So the graph should look like this. It's going up, and then it flattens out, and then it's going down. And then I erase all that and try to make a nice, neat version. So in between, it was a horizontal line, and then this side has to go down, and this side has to go down. And that basically covers all of the parts. Does anybody have questions on number 1? All right, then on to number 2. Suppose that you fell or you jumped out of an airliner at 32,000 feet. Then this function right here will be your height, which is basically saying that this is the initial height of 32,000 feet, and then this is gravity pulling you back down to Earth. So how long is it going to take until you hit the ground? Well, this thing right here is given the height. If you're on the ground, do you know what the height is? Somebody? Well, say if you're laying on the ground, what's the height?
0.
0. So in other words, plug in 0 for H, or the left side. And then solve for the T. And you could use the quadratic formula. You could complete the square. You could try to factor it. You could also just move this 16t squared to the right side. It becomes positive. And then divide both sides by 16. So 16 will divide into a 32 2 times, and then the zeros will just stay there. So it's going to be t squared equals 2,000. And then take the square root of that. So what's the square root of 2,000? The square root of 2,000. So I'm going to go with 3 decimals. Let me change my calculator back to 3. So 44.721. 44.721, and that would be in seconds. So almost 45 seconds of free fall. Then in the next question, the keyword is fast. So how fast? That means the derivative. So if the original function gives you the height, then the derivative gives you the velocity. So for that, we could just use the power rule. So for the negative 16t squared, you take the 2, bring it in front and multiply, and then subtract 1 from the exponent. So h prime will equal negative 32, and then t to the 1. And then for 32,000, you could look at it like it's 32,000 times x to the 0, because x to the 0 equals 1. So 32,000 times 1, that's the same thing. And then do the power rule. The 0, you bring it in front and multiply, and then subtract 1 from the exponent. But because it's 0 times 32,000, it's just 0.
Sorry, where'd you get the x0 from again?
So I was taking the derivative of 32,000. And usually I just say the derivative of a constant equals 0. But the reason that it equals 0 is because you could take 32,000 and you could rewrite it as 32,000 times 1. And then I'm replacing 1 with x to the 0. Because that way I can then show by using the power rule that the derivative will be 0. Because it's 0 times 32,000.
Okay.
And then the next thing to do is plug in the 44.721 seconds. So negative 32 times 44.721. So I could just say, take the last answer, 44.721, and multiply by a negative 32. And it's 1431.084. And then the negative means that the person is going down. So it equals negative 1431.084. So that's the velocity. And then the units, well, the height is given in feet and the time is given in seconds. So right now, this is in feet per second. I think I'm going to need to write it down here because I didn't give myself enough space. So this is in feet per second. But then in the directions I say, give the answer in miles per hour because I'm not really that familiar with feet per second. But I do know miles per hour because I drive a truck every day and I understand miles per hour. So I'm going to change it to miles per hour. So to get rid of feet, so if you have 1 mile, that is 5,280 feet. And of course, I could have put the 5,280 feet on top and the 1 mile on the bottom, but I did it this way. That way, the feet on top here will cancel the feet on bottom there. And then for the seconds, so there's 60 seconds in 1 minute. And then that way the seconds on bottom can cancel the seconds on top. And then just one more step, there's 60 minutes in 1 hour. And then the minutes and the minutes will cancel. And now it's in miles per hour. So it looks like I need to take my original negative 1431, whatever, multiply by 60, multiply by another 60, and divide by a 5280. And hopefully I can remember all that when I go to the calculator. So take the last answer, multiply by 60, multiply by 60, and divide by 5,280. Wow. So the person would be going negative 975.739 miles per hour. So that was negative, oops, I need a pencil. Negative 975.739 miles per hour. Which isn't exactly what would really happen because there is wind resistance and there's also this such thing called terminal velocity, the very fastest that an object can go from a certain height. But if there wasn't wind resistance, that's what would happen. Does anybody have any questions on that one? All right, then on to the next one. So where is the derivative equal to 0 for this function? So first of all, use the power rule. So the derivative for 2x cubed. So you bring the 3 in front and multiply, and then subtract 1. So that's going to leave 6x squared. And then for the next one, bring the 2 in front and multiply, and that's going to leave negative 6. And then when you subtract 1 from the exponent, it's going to be x to the 1, or just x. And when it's a number times x, well, the derivative of x is just a 1. So when it's a number times x, the derivative is just that number, negative 36. Or another way to look at that is, the derivative tells you the slope. Well, if you just have the line y equals negative 36x, well, from algebra, then you know that the slope is sitting in front. So that means that the slope, or the derivative, just equals the number in front. And then for that 6 right there, the derivative of just a 6 is 0. Then the next thing is set it equal to 0. So not plug in a 0 for x, but plug in a 0 for y prime. So on this side, put a 0. And then solve for x. Well, for one thing, I could factor out a 6 from all of these. That would leave x squared minus x minus 6. And then I could use the quadratic formula, but I tried to make this one up so that we could factor it. Let's see if it works. So x and x will be x squared. And then in order to get a 6, I'm going to use a 2 and a 3. And because it's a negative 6, the signs have to be opposite, like a plus and a minus. And then I think that works because the middle term, this would be positive 2x. And when you multiply the first one and the last one, that's going to be negative 3x, which leaves behind negative x, which is correct. So because this function had a squared, that means there's supposed to be 2 answers. So set this one equal to 0 and set this one equal to 0. And then the 6 does not have an x, so that's not going to help you solve for x. It's just going to be these two. So x equals negative 2 and x equals a 3. So then what's happening at those points? So now I'm going to graph the original problem. And see what's happening at negative 2 and also at 3. So y equals, the original problem was 2x raised to the third minus 3x squared minus 36x plus 6. And let me change the window. Negative 10 to 10 on the x-axis, negative 10 to 10 on the y-axis. Okay, well, at least now I could see the graph. But the y values seem to be much bigger than what's showing up on the graph. So what I could do with this calculator, it's on the iPad, so I could just go like this and go like this. At least I think I can, in theory. Okay. Or let me go back to the way it was. It was something like this. Or what I could do is on the calculator, if you just go to trace and you plug in the number -2, it'll say the y value is 50. So I needed to go up to at least 50. And if you hit trace and you put a 3, it says the y value is -75. So then if it was a regular calculator, I would then go to the window. The x's are fine, but the y's, I'll just make them both 75. -75 to +75. And actually, if it's going to be 75, I should probably go just a little bit more, like to 76, to make sure that it's on the screen. And then graph. So right there is where x equals -2. And then the little cursor right here is even saying that is the maximum value. So that's when it gets to the top of that hill. And then when I plug in the 3, when I plug in the -3, that's when it's down at the bottom. So when you take the derivative and set it equal to 0, it could tell you where there's the minimum. It could also tell you where's the maximum. So then finally, to answer that question, so there was a maximum value when x was -2 and then y was 50. And there was a minimum value when x equals 3 and y equals -75.
I have a question.
Yes.
So is that when it says y prime equals 0, is that like in terms of like the slope, or I don't really understand the question.
Right. So the function went like this. And then right here was x equals -2. So if I were to have a point on this side, then the tangent line would be like this. And because that little red line is going up, then slope is positive.
So it is talking about in terms of slope, right?
Yes.
Okay.
And then if you picked a point on this side, the line would be going down. So the slope is negative. And when you get to the top, then the tangent line would be horizontal, which means that the slope is equal to 0. So that's what this part was saying. When does the slope of the tangent line equal 0? And then as we saw with the airliner problem, the derivative is also the velocity. So it's also saying when is the velocity equal to 0? So if this was an object that was flying up and then going to go back down, right at the top, its velocity would be 0. So going up would be slope positive or velocity positive, and going down would be slope negative or velocity negative. Okay, now When I said that was a maximum right up here, it's actually called a relative maximum. But we say it so often, we don't usually say the whole name, relative maximum, but that is its full name. Just like my nephew's name is Maximiliano, but everybody calls him Max. Because relative max is referring to this. If you look at the rest of the graph, is this really the biggest or the maximum it ever gets? Well, it went down and then it went back up like this. So when it's over here, it's actually at a higher point than this. The relative means in its own neighborhood. So within its own neighborhood, that is the tallest point. And then this one would be the relative min or relative minimum, because in its own neighborhood, that's the lowest point. So any other questions on number 3? Okay, then on to the second page. Find the second derivative. So the derivative of the derivative. So you could say it this way. That's the more formal way to say it. Or you could just say y double prime. So with this function, I could start by rewriting it as x to the negative 1. That means the same thing as 1 over x. And then use the power rule. So take the negative 1, bring it in front and multiply, and then subtract 1. So y prime equals negative 1 times x to the negative 2. And usually I say don't leave any negative exponents, but I'm not done yet because I still need to find the second derivative. So I'll worry about the negative exponents at the very end. So now take the negative 2, bring it in front and multiply, and subtract 1 from its exponent. So y double prime will be a negative 2 times a negative 1, so that's just 2, and then x to the negative 3. And now that I'm done taking the derivative, don't leave any negative exponents, so just rewrite the x to the negative 3. So the final answer is 2 over x to the 3. Now for part B, we're going to need to use the quotient rule. And the quotient rule goes like this. If you're dividing two things, like the 2x and the x cubed plus 1, and you're supposed to take the derivative of all that, well, you start on the top. You take the derivative of the top one, and then leave the bottom one alone. Just copy it down and multiply. And then it goes minus, copy down the top one, a, and then take the derivative of the bottom. And then it's all divided by, the bottom gets squared. So that's how we're going to find the derivative. So the top is the a and the bottom is the b. Okay, so start on the top. The derivative of 2x will just be a 2. And then the bottom, you just copy it down. X cubed plus 1. Then it goes minus, just leave the top one alone, 2x. So that's this part. And now take the derivative of the bottom one. And the derivative of x cubed is going to be 3x squared. And the derivative of 1 is 0. So it's 3x squared plus 0, or just 3x squared. And then for the last part of the rule, square the bottom. So right now, it might be tempting to say x cubed plus 1 right here is going to cancel x cubed plus 1 right there. But you cannot do that, because if you're going to cancel those two orange ones, you also have to be able to cancel it right here. You have to cancel it everywhere if you're going to cancel it. And because this one doesn't have x cubed plus 1, it means that we cannot cancel x cubed plus 1. But what I could do is multiply this out and then combine like terms. So on the top, there's going to be 2x cubed plus 2. And then when you multiply these two, that's going to be minus 6x cubed. And at this point of the semester, we don't have the chain rule. That's next week. So that means we're going to have to go ahead and multiply out the bottom part. So I'm going to just do that on scratch paper real quick right here. X cubed plus 1 times another x cubed plus 1. That equals x to the 6 plus x cubed plus another x cubed, and finally plus a 1. So the bottom equals x to the 6th plus 2x cubes plus a 1. Does anybody have any questions? Okay, so that was my scratch paper. Then I still need to simplify this before I could take the second derivative, because on the top, I could combine those two terms. So that's going to leave behind negative 4x cubed and then plus a 2. Okay, now the first derivative is done. Now it's time to find the second derivative. So use the quotient rule again. So you start on the top.
You couldn't cancel right there the x cubed.
So you can only cancel when it's factored. So like if you had, so if you had something like this, so then in order to cancel, what I would need to do is factor on the top, factor out a 2. On the bottom, I could factor out a 2.
Oh, okay.
And it would leave 3x plus 4. And then the 2 on the top and the 2 on the bottom could cancel. But with this one, the top can't even be factored. I mean, you could factor out a 2, but the bottom part doesn't have a 2 that you could factor out. So there's nothing common that's going to cancel. Okay, so for the chain rule, take the top and the bottom, start by taking the derivative of the top. So that would be the 3 goes in front and multiplies, so that's negative 12, and then subtract 1 from the exponent, so that's going to be negative 12x squared. And the derivative of 2 is 0. And then just copy down the x to the 6 plus 2x cubed plus 1. And then I'm going to need to move it over because I'm running out of space. And then it goes minus. This time, just copy down the top part, negative 4x cubed plus 2. And now take the derivative of the bottom. So the derivative of x to the 6 will be 6x to the 5th. The derivative of 2x cubed is going to be plus 6x squared. And then the derivative of 1 is 0. And then the bottom has to be squared. And then the last thing to do is you need to combine like terms on the top. So I need to go ahead and distribute this. So it's going to be negative 12x to the 8th, negative 24x to the 5th, and negative 12x squared times 1, so negative 12x squared. And then multiply these. So I'm going to just keep the negative right there in front of the parentheses and just worry about multiplying what's in the parentheses. So negative 4 times 6, that's going to be negative 24x to the 8. Then multiply it with the last term. It's going to be negative 24x to the 5th. And then finally, distribute the 2. So plus 12x to the 5th. And then finally, the last one times the last is going to be plus 12x squared. And the bottom part, you don't have to multiply it out. Just leave it parentheses and squared. So for the final answer, you could just leave the bottom part in parentheses. And really the only reason I needed to multiply out the top is because there are like terms to combine. Like for example, this has an x to the 8 and this has an x to the 8. So combine those. Well, because of these two negatives, that's actually going to be a positive 24 x to the 8. And 24x to the 8 and then minus 12 will be positive 12x to the 8. And then how about the x to the 5ths? Well, right here, when you combine those two, that's going to be a negative 12x to the 5th. But then this negative still has to apply, so it's actually going to turn it into a positive 12x to the 5th. And then a positive 12x to the 5th with this negative 24 leaves behind negative 12x to the 5th. And last, the other like terms are the x squared. And this negative has to be applied to it. So it's actually a negative 12x squared in that last green bubble. So negative 12x squared with another negative 12x squared is negative 24x squared. And once we've combined the like terms, then it's done. That one was a little more work than I thought it was going to be. Okay, so now I think I need to take this and move it down here. So this right here is actually coming from the chain rule. And the chain rule isn't covered till next week, but we could still do it by using the product rule. So if y equals 5x plus 1 squared, then I could rewrite that as 5x plus 1 times another 5x plus 1. So that's what the squared means. And the product rule goes like this. So you have two things that are being multiplied, an a and a b, and then you're supposed to find the derivative of that. So you take the derivative of the first one and then just leave the second one alone. Plus, leave the first one alone and take the derivative of the second one. So it's basically saying you have to take the derivative of each one, but you can only do one at a time. For this part, you can only take the derivative of A, and for this part, you can only take the derivative of B. So using the product rule. So this is the first one. The derivative of 5x is just a 5. And the derivative of plus 1 is plus 0. So that would be 5 plus 0. That's just 5. And then just copy down this one. 5x plus 1. Now just copy down the first one, 5x plus 1, and take the derivative of the second one. So that's just a 5. Now to make it look like the answer, for this first one, it's 5 times the parentheses. Well, I could also just put parentheses 5x plus 1 and move the 5 to the end. And then it's saying you have this parentheses times 5 plus another one that's exactly the same. So if you're adding two things and they're exactly the same, that means you have two of them. So we have two of them that say parentheses 5x plus 1, and they both have a 5 at the end. And that is exactly what I said the answer was going to be. So we actually did prove it. Now, next week, we're going to be doing the chain rule. So instead of doing that long process that we just did, here's how the chain rule works. So it's going to save doing all of this work. It goes like this. Well, first of all, the power rule says take the exponent, bring it down in front and multiply and subtract 1. So I'll have 2 times parentheses 5x plus 1 to the 1. And then the chain rule goes, well, wait a second. what about this guy? You never took the derivative. So then the chain rule goes, oh, now take the derivative of 5x plus 1, and the derivative of 5x plus 1 is a 5. That's the chain rule. So we're done in one step instead of, what's that, like 4 steps? 1, 2, 3, 4 steps. Instead, we're done in just one step.
I have a question.
Yes.
So for the product rule, um, A is A is one. So when you factor out the when you expand 5x plus 1 squared,
Yes.
uh, one half is A and the other half is B. So 5x plus 1, that's A, and then 5x plus 1, that's B.
Yes.
Okay.
So this one was A and this one was B.
Okay.
So before we do the last one, let me just do one more with the chain rule. So with this one, I raise a 7x squared plus 8x to the 19th power. And if I tried to do it using the product rule, then I would have to write this out. I would have to write out 19 of them. And then I'd have to use the product rule 19 times. That would not be fun. But with the chain rule, it's easy. You just take the 19, bring it in front, and then subtract 1. So y prime is going to equal 19. Leave the parentheses alone. And now it's to the 18th. And then the chain rule goes, hey, what about the inside part? You never took the derivative of the inside. So then you just do that last. So the derivative of 7x squared, the 2 goes in front. So that's going to be 14x. And the derivative of 8x is just an 8. And then we're already done. Okay, so then where was number 6? Whoa, that's too big. No, that's good right there. Find the equation of the line tangent. So if you're going to find the equation of a line, then you need to know the slope, and you also need to know a point that it's going through. Well, for this one, it's saying x equals 1. And then to find out what y equals, just plug that 1 into the function, and it's going to be 2 times 1 cubed minus 5 times 1 divided by 1 squared. Or in other words, the y value is going to equal, let's see, on the top, that's going to be 2 minus 5. 2 minus 5 is negative 3. And then on the bottom, we're dividing by 1. So it's negative 3 divided by 1. The y value is negative 3. And then in order to get the slope, that's going to come from the derivative. So this one, it has the top and the bottom. That means we need to use the quotient rule. And you always start on the top, the derivative of the top. So the derivative of 2x cubed, bring the 3 down in front, that's going to be 6x squared. And the derivative of negative 5x will just be negative 5. And then that gets multiplied with the bottom function just as it is. So just copy down x squared. So the formula goes derivative of the top and the bottom left alone minus the top left alone and then derivative of the bottom. And then the whole thing is the bottom gets squared. That's the quotient rule. So we've done the first two parts. Now minus, and make sure you put parentheses. The a is left alone. So that's 2x cubed minus 5x. And then the derivative of the bottom. So derivative of x squared is going to be a 2x. And the last part of the formula is the bottom gets squared. So x squared gets squared. Now, earlier when I had one like this, I had to do a bunch of algebra to simplify it. But for this one, we're just going to plug in a 1 anyway. So you might as well just do that now and then simplify it. So the derivative, when you plug in a 1, is going to be 6 times 1 squared minus 5, and then times 1 squared minus 2 times 1 cubed minus 5 times 1, and then multiplied with 2 times 1. And then 1 squared gets squared. So how much is this? Well, right here, that's going to be 6 minus 5, which equals 1. And then 1 times 1 is just going to be a 1. And then this part in red is going to be 2 minus 5, so that's negative 3. And then negative 3 times 2 is negative 6. But then it's multiplied with this negative, it becomes positive 6. And then it's divided by 1 squared is 1, so the bottom is just 1. So the slope equals 7. And then the point was 1 comma negative 3. And then finally do the point slope formula. So y minus a negative 3 equals, the slope is 7 times x minus 1. And then on the left, the two negatives will cancel. So it's really y plus 3. And then distribute the 7. So it's 7x minus 7. And then subtract 3 from both sides. So it's going to be 7x minus 10. And with the last couple of minutes, I just want to graph it and see if I did it right. So when you graph, always graph the original problem, not the derivative, but the original problem, which was 2x is raised to the third and minus of 5x. And it was divided by an x is squared. Okay, that's what the graph looks like. Fine. And now graph the answer that we got, which was 7x minus 10. And then the point was when x equals a 1. So if I put when x equals a 1, so on this calculator, when I plug in the 1, it automatically gives me the dy dx. That's the derivative. So it says the derivative is a 7, which is what we got. And if you look at the graph, and especially if you zoom in on that point, you'll see that it's just hitting right there when x equals a 1. So that definitely looks right.